Today we will solve inequalities that contain variables on both sides of the equation. Let's look at some examples. All right, let's start with the first one. X is greater than or equal to 2x plus 3. I'm going to move this x over because I want to keep this positive if I can. All right, so I now have 0x plus 3. So 0 is greater than or equal to x plus 3. Now I need to get x by itself. Since 3 is being added, I'm going to subtract. Now I get negative 3 is greater than or equal to x. Remember to graph it. All right. So we have negative 3, and it's included, greater than or equal to, so I'm going to do a closed circle here. But now I have that is greater than or equal to x. So that means x has to be less than or equal to negative 3. If negative 3 is greater than x, then that means that x has to be less than or equal to negative 3. So there's our answer for our first example. Let's look at number 2. All right, again, I want to keep x positive if I can, so I'm going to take the smallest x value and move it over. So now I have 2x minus 2 is greater than 5. I'm going to add 2 since it's being subtracted, 7. And then I'm going to divide out the 2 here. So x is greater than 7 halves. 7 halves is the same as 3.5, right? So I have my number line here. I'm going to do 4, 3, 2, and 1. So 3.5 is probably about right here. Open circle because it's not including the number. And x is greater than. So I want all the bigger numbers. So there's my answer for number 2. Let's look at number 3. I need to distribute here, right? I need to distribute everything into the parentheses. So I'm going to have 4x minus 8 is greater than or equal to 2x minus 2. 4 times x is 4x. 4 times negative 2 is negative 8. 2 times x is 2x. 2 times negative 1 is negative 2. So now I'm going to subtract the 2x because remember I'm moving over the smaller number to try to keep everything positive. So I have 2x minus 8 is greater than or equal to negative 2. I'm going to add my 8. Since it's being subtracted, I need to add it to do the opposite. Greater than or equal to 6. And lastly, I need to divide out that 2. X is greater than or equal to 3. So I'm going to graph that again. Let me see, we'll do 1, 2, 3, 4, 5. Greater than or equal to, so we're including the number. And all the bigger numbers. But sometimes we get answers that don't look as nice and pretty and straightforward as this. So let's look at some examples that might get a little bit confusing. All right, what if we had 3x plus 2 is less than or equal to 4 plus 3x? So let's see what happens when we subtract the 3x to move it over. Now we get 2 is less than or equal to 4. So in this case, that's a true statement. 2 is actually less than or equal to 4. In this case, if you completely eliminate your variables and you're left with two numbers like this and a statement that is true. So this is a true statement. Then your answer is all real numbers. Because if you put a 1 in here, let's say you put in a 1 for x, you get 3 times 1 plus 2. It's greater than or equal to 4 plus 3 times 1. So that's 3 plus 2 is 5, 4 plus 3 is 7. So that's true. What if we put in a 5 in here? That's 15 plus 2, that's 17. That's 15 plus 4, that's 19. This is also true. So no matter what I put in for x, I'm going to get a true statement. So x can be any real number. So all real numbers. Let's look at another example here. All right, so again, we distribute first. So we get 2x minus 3 is greater than or equal to 2x plus 16. I'm going to subtract to move it over. And I get negative 3 is greater than or equal to 16. That is a false statement. Negative 3 is definitely not greater than or equal to 16. So because this is a false statement, no solution. There is no solution. This is a false statement. All right, so if you get two numbers, you've eliminated your variables, and it makes a false statement, then there is no solution. If you would like more practice with these inequalities, you can go to IXL underneath Algebra 1, section K 7 through 11. And I'll see you in Zoom.